Okay, so we're going to look at the point of intersection between these two. And this can be hard to look at because of our fractions, right? Being above two whole numbers. If we remember back to our fraction rules, if we're subtracting fractions, or let's say they were adding fractions, what they've done here is they've just kind of simplified it, but it can be hard for us to look at. Another way you could write this is y is equal to 2x over 7 minus 5 over 7. And this could be written as y equals 7x over 2 minus 3 over 2. Okay, they're all over 2, so they just simplify it by putting one line. And then even here, this variable looks odd, right? You've got 7x over 2. This is really, the coefficient is really 2 over 7. So I could also write it like this. Y is equal to 2 over 7x. So our coefficient is 2 over 7 minus 5 over 7. And y is equal to 7 over 2. That's our coefficient. Here's our variable, minus 3 over 2. So now this is a little simpler to look at. And maybe this is what we're best with. Maybe you're best with what's on top. We'll work with this one at the bottom. We've got to find the point of intersection. Well, luckily, this has already been set equal to y, and this has already been set equal to y. So we can set them both equal to each other. 2 over 7x minus 5 over 7 is equal to 7 over 2x minus 3 over 2. Okay? So because they were both set equal to y, essentially this is equal, big long equal sign, to this here. Okay? So now that we've done that, if you're not strong with fractions and you don't like working with them, we can look for a common multiple between 7 and 2. Any common multiple will work. So common multiple is two numbers that they multiply to, and if you don't want to spend the time looking at it, you can usually just multiply the denominators by each other. So 2 by 7, 14. Yeah, 14 is for sure a common multiple. So let's multiply this entire equation by the value of 14. Okay. So what that would look like, and instead of me working it all out, I'm just going to rewrite this again. But I'm going to write times 14, right? And if you're multiplying fractions, it would technically be 14 over 1, but I don't need to put the 1 because it's not going to change anything, right? Minus 14 times 5 over 7 is equal to 14 times 7 over 2 with our x minus 14 times 3 over 2, okay? And this is what we could do to simplify our multiplication. Because this is multiplied by, these are going to affect each other. This is going to be 14 over 7. Well, if I divide 14 by 7, this goes away, and this is just a value of 2. So I'm going to reduce everything. I'm going to scratch that out and make that 2. I'm going to scratch this out and make this 2. Here it's kind of a little different. When I do 14 divided by 2, it makes this 7, and it makes this 7. So the numbers I'm multiplying by now are a little simpler, stuff I can probably do in my head. For instance, 2 times 2 is x. And we know the denominator's gone, it's been canceled out, or technically they've all been turned into 1s, but a lot of times in math, teachers will tell you they've been canceled out. The reason it's turned into 1 is if you divide anything by 1, it doesn't change it, right? So 2 by 2, that's 4x. 2 by 5, that's minus 10. And now I'm done all my fractions. 7 by 7, that's 49x. And 7 times 3, and there's a subtraction sign here, is subtract 21. And now this is something that's probably much more familiar to work with. I got to get my like terms together, so I'll bring this 4x over here and the 21 over here. This becomes 21 minus 10, and this becomes 49x minus 4x, okay? This becomes 11, this becomes 45x, and x is equal to 11 over 45. That gives us an x value. Technically, we need to plug it back into one of these, okay? And we can, and that might be a difficult part because we're plugging a fraction in. So let's just take this equation, 7x minus 3 over 2, and I'll plug that fraction in. We'll have to go through our fraction rules. Y equals 7x, and I'm going to, 7x, thank you, minus 3 over 2, right? Okay, so I'll use substitution. Essentially, I'm going to replace the x value with that fraction. So y is equal to 7 times 11 over 45 minus 3 over 2. All right, so this is where we need to be good with fractions. I'm going to keep everything in fraction form. I like working with fractions. It's very, very exact. I know that 7 times 11 over 45 is 77 over 45. Okay? I'm also going to change everything. I'm going to change my other number on top, this 3. I'm going to put it over 45, which means I need to multiply it by 45. And there may be a number I can reduce it by, but this will be okay. That'll be 5, carry the 1. That'll be 135 over 45. Okay? And I'm going to keep the bottom here, but I'm going to kind of just ignore it for now. Focus on our adding, subtracting on top. That will be, what will that be? 8 and 30, 68. So maybe negative 68. Can you check that for me? Over 45. And then all of it divided by 2.
Negative 58.
Oh, 58? Too many 10s there. Oh, that does make sense. Okay. Okay. So we have our negative 58. Now I have a fraction divided by a number. Well, that means they all mean divided by. So I'm going to rewrite this part. I know it's not common to see it this way, but y equals negative 58 over 45 divided by 2. And if you remember your rules for dividing fractions, you turn into a multiplication question and you invert the second number. So this is technically 2 over 1. Well, I can write it now as y equals negative 58, it's lagging a bit, over 45, times 1 over 2. The number on top is going to stay the same, and the number on bottom is going to double. So this becomes negative 58 over 9. 58, there you go, over 45 times 2 is 90. And I can reduce it to divided by 2. That's going to give us something like
9 over 45.
Is that 29 over 45? Yeah, probably right.
Negative.
Or negative 29 over 45. You're way better at this than I am. Perfect. 29.
That's
a
just
prime.
what I got from dividing 58 over 45.
Oh, okay, good. And there you go. So that's your y value. So your answer reads 11 over 45 as your x, and negative 29 over 45. And they're both over 45, which works out really nicely as our y for our point of intersection. So a lot of stuff. We need to be strong with our fractions and those ideas. Technically, a question you can be given in grade 10, just be kind of tough for you to work with, right?